Welcome back to Clean Code and Programming Principles, the Ultimate Beginner's Guide. I'm Spiros, and this is the Programming Duck channel. And in this video, we're going to cover the foundations of programming principles, which are the motivations and the reasons behind why we have the programming principles that we do in the first place. So let's get started. The first thing to note is, what are the requirements of software? And that is an extremely broad question. So what I mean specifically in this case is the requirements of software from the point of view of good code, from the point of view of programming principles and things like that. And the way I see it, there are two main requirements. And those are that, one, software should work as intended. And of course, this should be obvious to everyone, right? I don't think this needs much explanation. But the second one is that software should be easy to change. And there are a few reasons why it needs to be easy to change. But long story short, it's because that's just the nature of things. That is how we work with software. We change it all the time, right? So when we work as programmers, we work in iterations. It's not possible for us to write a complete program from start to finish in one go. We've tried doing that in the past. We used waterfall, right? Where we would design software for a couple of months, and then we would get on and code it and integrate it all at the end. But that's very difficult, and it turned out that it didn't really work. So instead, what we do is we write a bit of code today, right? We create a feature, we put it through code review and all that stuff, we submit it into the code base and so on. And then we come back tomorrow and we write some more code. And in the process, we change the code we wrote yesterday. And then another reason is that requirements change all the time, which again is just the nature of things. This is how software is. And then also we create bugs, right? So even if we could write the software in one go, even if requirements never change, we still create bugs, which means we need to come back tomorrow and change the code. So that's an unchanging rule. Software changes all the time. So for our sanity, and to make it easy for us to work with, we have to write code that's easy for us to change. Otherwise, we're just wasting our time. If it's hard to change, we might create bugs and all that stuff. So I hope that makes sense. The next thing to consider is our human limitations. And those mean that certain types of code are just difficult for us to work with. Those are pretty common sense as well, but there are things like we can't remember too much at any one time. And so the code that we write needs to be written in a particular way to avoid this being an issue. So for example, if we have a file called X and we have a file called Y, and we want us, we have 1,000 more files because that's how code bases work, especially large code bases. So if we change X, which we will do, we can't have Z and Y breaking. We can't have them depending on X in bad ways because we'll never remember that. And if we're new to the code base, we'll never even know that to begin with, let alone remember it. So that's the kind of stuff. These kind of things are things we need to write code a particular way in to avoid them becoming an issue. But yeah, one thing is we can't remember too much at any one time. Another point is that we get impatient, we skim things often, we have bad days, and we get bored. So the antidote to this is basically to make code as easy as possible for us to work with. It must be immediately understandable. We shouldn't waste time having to understand it, and changes should be easy. Because, you can see how if those things aren't there, this point would be a problem. Another thing is that we like things simple. So complicated things are disproportionately more difficult for us to work with than simple things. And, probably that's partially because of the first two reasons, But yeah, we like things simple. So again, code should be as simple as possible for us to work with. It should be extremely simple. Another one is that we make mistakes everywhere all the time. And of course, this doesn't just apply to programming. This applies to everything in life. So again, this is why we use practices like testing, strong type systems, linting, and whatever else, because we make mistakes. And if we didn't make any mistakes, those practices would be completely unnecessary and a waste of time. And finally, we are bad with repetitive work. And again, this is probably because we get impatient, right? It's usually easy enough for us to make one change, but having to make the same change 3 times, you just feel your attention going a bit. I'm sorry, if we were paying full attention 100% of the time to all of those changes, we wouldn't make mistakes as often. But again, it's just human nature. Don't know why it happens like that, but that's just how we are. So yeah, these are important to understand because they affect the next part of, okay, how do we write code to overcome these then? Okay, so next, how we work. And we need to work deliberately. And this, by the way, is a point from the pragmatic programmer. In there, it's phrased as, don't program by coincidence or something like that. But yeah, that's what it means. It means that when we write code, we shouldn't be writing some random stuff until we get something that works. Because that process doesn't really scale very well. So if your project is small, don't get me wrong, that's going to work just fine. You write some code, you'll open the browser or whatever it is, and you'll see that it works, and you'll be like, okay, great, my code's working, let's submit it. And that's fine. But the problem is that if you're programming like that, programming by coincidence, then frankly, you don't know what you're doing. Because if you knew what you were doing, you wouldn't be programming at random, you would be deliberate about what you're doing. The problem with this is that when the code base scales, if you program by chance, then you don't know what could break and you can't test everything like you can test with a small application. So it's up to your tests. It's up to your tests to catch the bugs. So if your tests are good, then fine, maybe this will somewhat work. But if they're not, then you might have a problem. Basically, for you to have the highest chance that you're doing the correct work, you have to know as much as possible about what you're doing, and you need to be as certain as possible that you're doing the correct thing. So that's how we work. We work deliberately. And how do we work deliberately? We need to understand what we're doing as much as possible, which again means that the code should be simple and easy to understand and work with. So if we combine the requirements of software, our limitations, and how we work, then all of these point to a particular way for how we have to write code. And that's the following of this slide, among some other things that the programming principles cover. But those are: code should be simple and easy to understand for a lot of reasons, but for some basic reasons, it's so that we can understand it quickly without wasting time, and so we can understand it well enough to not make mistakes. Because, by the way, if code works differently to how you intend it to, then that is a bug by definition. And also, if you work on a particular piece of code where you don't fully understand how it works, you'll create more bugs. And it's easy to see how. Say you have code X and it does something different to what you think it does, and you modify a small part of it now, believing that now it works, but it doesn't, because the rest that you didn't modify works differently to how you think it does. So now this part works different to how you think it does. This last bit that you modified works fine. But again, the whole thing doesn't work how you intend to. Therefore, you have a bug. And again, you might catch it. If you have good tests, you might catch this stuff. But that's an if. That's not a certainty. So yeah, if you work on something that you don't understand in the code base, you might create more bugs. All right, another point is that code should be without hidden dependencies. And what this means is that you should be able to modify code X without breaking code Y and Z. And the problem with this point is if you don't adhere to it, then you will break code Y and Z. And not just that, you're then going to have to go modify code Y. And by doing so, you're going to break code A, B, and C as well. And you're going to have a chain Maybe you've had experience in this in your own code base where you modify something and then you have to chase tons of files so it actually works again. And anyway, you want to avoid that. And that's one, so that you can do your work easily without having to change 1,000 things. And two, more perhaps more importantly, because the memory thing, right? Who's going to remember that if you modify code X, code Y and Z are going to break? Like, if you haven't touched that area of the code base in a year or something, you're not going to remember that. And if someone new works in that area of the code base, they won't even know. There won't be anything to remember. They won't know in the first place. So yeah, you want code without hidden dependencies. And another point is that you want code to be organized well. And that's so you can find what you need quickly, so that the code organization makes sense, so that when you look at the file system or whatever, it's easy to understand. It helps with all of those things. And not only that, it also helps with having concerns, meaning responsibilities of the code, separated. So again, if you have a class called circle, you know what that file does because it's organized well. And I hope that makes sense. And then finally, we want to avoid repetitive work. So again, we use the principle of abstraction here and things like that. And that's pretty much it. So I hope all of this made sense. I hope this understanding helps you. And I definitely think that knowing these points is really important with learning and understanding programming principles, including how to apply them much better. But yeah, so that's all for this video. So if you liked it, then please click the like button. If you want to be notified of the rest of the videos as they're uploaded, then please subscribe. It really helps the channel when you do those things. And finally, if you've got any comments or even counter arguments, then please leave a comment in the comments below. All right, thanks very much and see you on the next one.